Okay, guys, welcome back. Another lesson. I feel like I repeat myself every intro to this video, but I can't help it. What else am I going to say, right? Applications to graph and quadratics here. Okay, that's the title of this lesson. Today we're going to do 3 examples just to kind of give you a little variety. My notes, which are posted online, will go through some more examples that you can feel free to look at. Okay. Plus, I have some graph paper as well, so that way you can fit everything. So, if you take a look, I don't know if you know this. This is actually the largest steel. Man, why am I? It's escaping me. The largest steel arch bridge in the world today. This is actually located in Australia, Sydney. Okay, this is called the coat hanger, is what this bridge is called. You can I think, what I remember reading, I think you can climb to the very top of this and you can look out and see the wonderful sights up at the very top of that bridge. But you can see that the shape is a nice parabola, which can be represented by a quadratic. Okay, so just kind of a really cool intro to this lesson here. Oh, there we go. When we're trying to solve a quadratic, we're trying to figure out what solutions it has. And if you remember from a previous lesson, the solutions to an equation is where it crosses the x-axis. Looking at a quadratic, same thing. If the vertex is resting right there on the x-axis, we only have one real solution. When the vertex is below, and it's a positive a value for the quadratic term, we could see that we have 2 solutions for this guy. And then for the last one, we could see when the vertex is above the x-axis, we have no real solution. It could be below it too, just have a negative quadratic value, and it could be opening up downward. Therefore, it still would have no solution to it. Okay. Now, if I'm going to solve for this, I can see clearly that if I find the vertex and I know what the a value is, that can tell me before I even try to find an answer if this even has a solution. Okay? That's what is very important about this. So when we start solving these, we're going to try and find the vertex first. Here's our first example. Okay. I'm going to rewrite it on this whiteboard. Okay. So we have x squared minus 4x equals negative 4. We're going to solve this by graphing. Okay. Can you solve this differently without graphing? Absolutely, but this is just one method. My first step is to make this guy equal 0. So let's bring the 4 to the other side. So x squared minus 4x plus 4 equals 0. For my next step, I'm going to find the vertex. That's critical for right now. So if you remember, to find the x-coordinate, which is also the line of symmetry, you would use the formula negative b over 2a. Okay. My b value is negative 4. Oops. There we go. And the bottom value would be 2 times 1, because my a value in front of the quadratic term is 1. So this becomes what? 4 over 2, which gives me 2 as my x-coordinate. Okay? So just remember, that's your x value. Now, to find the y value, you just have to what? Plug that back in. All right, let's see what we get. So we have 2 squared minus 4 times 2 plus 4. We'll substitute that. And let's see, 2 squared is 4, minus 8 is negative 4, plus 4 gives me 0. Therefore, my vertex has to be 2, 0. Here's my vertex. Okay. So if I were to graph this, we'll go over 2, up 0. There's where it's located. Because this is a positive 1, I know that it's going to open up like this. Okay? Going back to the previous slide, I can tell that, hey, wait a minute. It has one solution, right? So one solution because the vertex is resting on the x-axis, and that solution is when x is 2. Okay, when x is 2, you get your y output, which is 0. All right. Now, here's the deal. I didn't have to make a table of values and graph any further, but don't think I couldn't. Don't you dare think I couldn't do that. I would put my vertex here in the middle, 2 and then 0, and then I would plot points to the left and to the right of the vertex, and I'd still try to figure out, where's the solution going to be. So for instance, let me just change this real quick. Sucks, I have to delete my very pretty graph. Let's give this example. Let's say that your quadratic looked like this, which means this has 2 solutions here. So what I could do, and let's say this is my vertex. So -2, -3. We'll just say as for instance. I'm going to plug points in, and eventually, okay, I'm going to come up with some sort of solution. And this isn't drawn to scale. I can tell you that right now. It is not drawn to scale by any means. Okay. Sorry about that. I don't know why it took longer in my head to write this down. Anywhere the y-coordinate's 0, the x-coordinate has to be solutions to this guy. Okay? So if it did have solutions, when you plot x, y points, you would see that in your table. All right? What do you think? Questions, thoughts, concerns, dilemmas? Of course not. You guys are perfect. You guys are awesome. Let's try another example out. Okay, let's do a number theory question. What's that look like? Well, here it is. We're going to use a quadratic equation to find 2 numbers with a sum of 4 and a product of 5. Now, how many of you have seen problems like this before? Come on, raise your hand. You know you have. If you haven't, this is your first time seeing it then. Could you guess and check? Yes, you could. You'd be here a long time depending on what they're trying to do here. Why not create a situation where we could figure this out more mathematically than just guessing and checking? So the sum is 4. The product, when they're multiplied together, is 5. Okay. What do I want to do? Well, how about, let me just do this for instance. If I don't know, I'm starting to reveal the answer. I was just starting to write it. So if I multiply these 2 numbers together, I get 5. But if I add these 2 together, I get 4. If I don't know something, you put a variable in there, right? You usually put x. So first number and second number. First number will represent as an x. Okay. What would the second number be represented as? Well, let me just give you a small little, we're going to doodle over here. Doodle. Okay. Let's think about this. If my first number is a 3, what do I add to it to get 4? Well, it'd be a 1. How did I get this 1? Well, I took the answer and I subtracted my very first number to get to that result, right? Okay, now let's do this. X plus what number gives me 4? Same principle. How do I find the missing value? Well, it'd be 4 minus x. Okay, and that's going to give me the sum of 4. So therefore, I could say that if this is x, my second number is going to be 4 minus x. If I add them up, I get 4. When I multiply them, I get 5. Okay? Does that make sense? Does that clear things up a little bit? Okay, my doodle's gone. I'm not much of a artist, so that's the best I got. Just numbers. I could paint numbers. There you go. I'm going to go ahead and solve this. I'm going to distribute that x to both terms. I get 4x minus x squared equals 5. Now going back to the very first problem that I solved with you, I said, okay, make this equal to 0 first. To do that, I have to subtract 5 to the other side. I'm going to put the quadratic term in the beginning, just because that's like our standard format. Plus 4x minus 5 equals 0. The answers to this quadratic will tell me two numbers that add to 4 and two numbers that multiply to give me 5. That's incredible, isn't it? That's so weird. It really is. We're going to find the vertex. That's our starting point. So negative b over 2a. Our b value is 4. My a value is negative 1. Divide them, I get 2 for that guy. Plug 2 back into the original. So negative 2 squared plus 4 times 2 minus 5. Oops. Not equals 0. We're going to see what that equals here. Let's see, this would be 4, right? This becomes a negative 4. And I really hope you guys, actually, let me exit the PowerPoint just real quick. So that way I can watch the video. Yeah, you can see that. Good. Okay. I had the PowerPoint slides presented on my laptop, which I'm recording, and it's hard to see if that's what you guys are looking at here. That's negative 4 plus 8 minus 5 for that guy. So let's see. We get 4. 4 minus 5 would give me a negative 1. So f of 2 is negative 1 for that. My vertex is located at 2, negative 1. Let's just do a quick graph. Over 2, down 1. So it's located right here. Well, where's it going to open up? It's going to go up or down. Well, the negative is implying that it's going to be opening downward. Just like that. Does that mean I have a solution? What do you think? The answer is no solutions. There doesn't exist two numbers that add to 4, and then when I multiply them together, I get 5. Okay, based on the quadratic that I provided here. Okay, if it did cross the x-axis, I'd make a table and then see what values would come up 0 for y's. And that'd be my answer. Okay. I have another example in my notes, but let's treat it this way. Let's change it. Let's make the sum 8 and the product, I don't know, 24. Well, my first number is x. My second number would be 8 minus x, right? And that's going to be multiplied equals to 24. It follows the same pattern. So even though I changed these values here, I'm still going to keep the same routine and procedure to figure out if those two numbers even exist. So in this case, no two numbers exist, no solution. Okay? It's pretty cool, isn't it? That you can figure something out using a quadratic. To be honest with you, when I first look at that problem, I don't think, hey, quadratic. No, I think, oh man, well maybe these two numbers work and I'll try it out. Okay? It's a little bit longer of a process. All right. One more example. One more to go. One more to go. There we go. Awesome. Okay. Sorry. Let me just... there we go. Okay, my last example, it's going to be a word problem. I know people love word problems, right? Guys can't get enough of them. A souvenir shop sells about 200 coffee mugs each month for $6 a piece. The shop owner estimates that for each 50-cent increase in the price, he will sell about 10 fewer coffee mugs. Ouch. Per month, how much should the owner charge for each mug in order to maximize the monthly income from themselves? From their sales. When you hear the word maximize, you might be getting visions of linear optimization, and no, we're not doing that. But when you hear the word maximize, when it comes to quadratics, I'm looking at a parabola that's opening not up, but it's going to open downward, right? So that means the A term in that quadratic part is going to be negative. Something to keep track of, okay? And that vertex, okay, that x value is going to be what? How much he's going to be charging? Or actually, the x value would be how many price increases he should have, but the y value is going to be how much he's going to be charging, right? So that's what you want to keep in mind when you're first looking at this problem, okay? And then start solving it. So, a little bit of a setup here. Income equals the number of mugs times the price. So we're going to let x be the number of times he increases the price by 50 cents. And then I of x is going to be the income. Here we go. Boom. I of x equals, okay, the number of mugs that he sells times the price of your mugs. Okay? Now, let's translate these words. Let's actually put them into algebra. That's the word I'm trying to think of. Sorry about that. I'm blanking out for some reason. Now, if we take a look at the previous slide here, we see that we have 200 coffee mugs that we're selling each month. That's the top. I'm not going above 200. But as soon as I have a price increase, I'm losing 10 mugs. Okay? I start with 200. Minus the 10 mugs that I'm going to lose for x. X represents, I'll put it up here. It's the number of price increases. Okay? So if I increase the price once, I lose 10 mugs. If I increase the price twice, I lose 20, right? 10 times 2 is 20, minus 200, I'm only selling 180 mugs. Times. Okay, let's talk about the price here. We start out with $6 for every mug, right? Yeah, 6. Sorry. I'm going to add 50 cents to it, right, times x for every price increase. So if I increase the price twice, that's $1. 6 plus $1, $7. Good. This looks like it's going to work for me. Okay? This is now my function. Looks pretty cool, huh? Really is. Now what do I do? It's a great question. What do I do, guys? Okay, I can't wait on you forever. Come on, what are we going to do? All right, well, you missed your chance. I guess I'm going to have to tell you. Multiply these two guys together, right? 200 gets multiplied to these two terms. The negative 10x gets multiplied to those two terms. Okay? I'll write it out fully so you can see it. 200 times 6 plus 200 times 0.50x. The first set of distributions. Okay, the next set of distributions would be minus 10x times 6 minus 10x times 0.50x for that guy. And once again, let me just double check. Let me just get rid of the PowerPoint here. Yeah, okay, you can't see everything. All right, everything so far so good. Let's simplify a little bit. 200 times 6 is 1,200. Plus half of 200 is 100. Don't forget the x. Minus 60x minus, what would that be? 5x squared, half of 10. We'll combine terms, and let's put it in the proper format. That negative 5x squared I'm going to put at the very beginning. 100x minus 60x is 40 x's, and then plus 1,200, just like that. Okay? Now, we already said that we would like to find the vertex. Okay, the vertex is going to tell me what price I should put for this, and it tells me how much income I'm going to get. So let's find the vertex then. You should be sick of this formula by now. It should be drilled in your brain. Negative b over 2a. So that'd be negative 40 over 2 times negative 5 for that guy. Hey, this is going to be nice. Negative 40 divided by negative 10 gives me 4. Hooray! Yeah! This is the x-coordinate. What else does it represent, though? We have context to this problem. What were the x's again? What were the x's again? Right? What do they represent? Do you see? Do you see? Hey, it's the number of price increases, right? So we need 4 price increases to maximize my profit. We're going to need at least 4. Now, what would that give me? Well, I'm so glad you asked. We're going to plug it back into here to find the price of it. Negative 5 times 4 squared plus 40 times 4 plus 1,200. Okay? 4 squared is 16 times a negative 5 would be negative 80. Plus, this would give me 160, so that gives me 80 plus the 1,200, so 1,280 bucks. Okay? So that's the max profit. Wow, that was weird. Okay. Hold on. That's not how you draw a circle. Boom. Okay, that's better. $1,280, given you have 4 price increases, that'll give me the max profit. Okay? Not bad, huh? And if I were to graph this, can I fit, you know what? I'm going to put another whiteboard in here. If I were just to graph this, boom and boom. Let's see, the would be what? 1, 2, 3, 4, and then up 12. What, 1,200 or no, 1,280? Whew. Boom. We'll say that's 1,280. All right. It's negative for the 8 term, so it's going to come down like this. Okay. Now we're not really solving for these guys right here. This problem, we didn't really want that. We just want to figure out what the maximum is. But think about what that means in terms of the problem. If I were to figure out where those solutions lie, that's where y's are zeros, right? According to the problem, that means he's getting no income. Finding the solutions to this will tell me what price increases will give him $0. All right? So if I were to add this on as an extra problem, you could say, okay, well, that's what this means. That's what the intercepts are, or the solutions to it. Okay? This problem, the vertex was important to find out the answer. The other 2 problems, the intercepts were used to figure out the answers to that problem. All right? And that's it. Okay, that's just some applications. We'll do some practice with us the next couple of days, but other than that, we're done. Hooray! Enjoy your day, guys. Have a good one. I will see you all on the next lesson.